Howdy, gang. Looks like most of us are here. So let's go ahead and get rolling. So today, we're going to talk a little bit about even and odd functions. This is the topic that I posted the supplemental material for last Friday because we lost time last week due to the holiday, but I want to kind of round it off. So a little more on transformations. Specifically, I want to talk about even, odd functions, function parity. And then we're going to move on to the next section, which is on combining functions. Later this week, we're going to talk a little bit about one-to-one functions and their inverses. And then we'll almost be ready for exam one. Exam one normally would have been, I think, this week, yeah. But because we lost that time last week, we're a little bit behind. We're about a half week behind. So instead of having exam one this week, it will be next week. So let me make another little announcement here. We're going to do it next Wednesday. So today we're going to talk a little bit more about transforming functions, and we're going to talk about combining functions. So we're going to finish up the even odd stuff here, and then we'll talk about combinations. Then Wednesday of this week, we're going to talk about one-to-one functions and their inverses. And then at the start of next week, we'll have a little review. The end of next week will be the test. Monday of next week isn't just going to be a review. I'll insert a little bit of new material because we're going to start talking about graphs. But yeah, exam one, rather than being this Wednesday, going to be next Wednesday. We're going to bump it back a little bit to make sure we have enough time for everybody to get through the homework, and then also to have enough time on the study guide. That matters a lot. I'll also have a quiz this week. Quiz one, you're going to solve in WebAssign, but the careful written solutions to that quiz, that's going to be your first study guide. So just to be clear, you need to hand in quiz one in two places. You're going to go through it in WebAssign and you're going to submit it there. That will count as your quiz one grade. The written solutions to quiz one, you're going to scan and submit on Canvas. So you must write neat, legible, organized solutions. Have I been redundant enough there? I got to be able to read them. Solutions to the quiz problems. And submit those scans of those solutions on Canvas. Thus, the Canvas submission counts as study guide one. Okay, so I want this to be really clear. I know you guys aren't college algebra students. You're a little bit more organized and a little bit more hardworking. You will be doing two things. So you'll be turning in your answers to me through Canvas. The answers that you're going to turn into me, those solutions, will be the solutions to the problems that you answer in WebAssign under quiz 1. So here's how it's going to work. You're going to go to WebAssign. You'll see an assignment that's titled Quiz 1. You go ahead and take the quiz. Then after taking the quiz and seeing how you do, you're going to go through and review which ones you got right, which ones you got wrong. And you're going to write out nice, neat, careful solutions to every single problem. All of them, not just the ones you got wrong, all of them. Those nice, neat solutions, you will then use your phone, or if you have an actual scanner, you will scan them. If you are using your phone, I highly recommend the following app. Where is it? Cam Scanner, I've got it here. This app, Cam Scanner. It's awesome. It actually gives you really nice scans with your phone. Please don't just send me a picture. I'm going to have the Canvas thing set up so that you cannot submit a PNG or JPEG or GIF. It has to be a PDF that comes out of an app like Cam Scanner. That's so I can get in there and annotate it. So I'll run through that procedure again. You're going to go into WebAssign and take quiz 1. After you finish quiz 1, you're going to review the answers. Right? Some you get right, some you get wrong. That is what it is. Then you're going to write out very neat, careful, perfect solutions to each problem, paying especial attention to the ones you got wrong, of course, on the quiz. Those nice, neat written solutions that you prepare after taking the quiz, you will scan and submit on Canvas as study guide 1. So I would like to have the quiz and everything due by, I want some time between then and the exam. So the exam is going to be next Wednesday. And here's what I'll do. The quiz on WebAssign and the study guide on Canvas, these will be due on the day of the test, which is next Wednesday. But I strongly encourage that you submit both, particularly the study guide, by Monday. Why? So I can grade the thing and give you feedback. So I can go in there and make comments and little notes and say, oh, this was wrong, this needs to be that minus sign should be a plus, watch out for your notation here, make sure you're reading the graph right, remember it's always X values, that shit. All the shit that you would get as comments on an exam, but with points taken off, I can give you on the study guide without taking points off. I'm not going to be correcting the study guides I'm not going to be grading them for correctness, I'm grading them for completeness, neatness, all of that stuff, and then I'll be writing in little comments that will help you on the test. So while I will take them on the day of the test, I encourage you to get that shit done as soon as you can. That way I can grade it and get you feedback as soon as possible. That way you can use that feedback as you study and prepare for the test. I would prefer to have them be due like before the test, but I know most people, myself included, have a tendency to procrastinate, and I don't want to punish you for that natural tendency. So instead I'll dangle this carrot, right? I strongly encourage you get them in by Monday so that I can give you feedback, because that feedback is really the purpose of the study guide. Yeah, the purpose of the study guide is so that we can talk about problems and I can help you with them before the test. That way it's actually useful for the test. Is this all nice and clear? So the study guide will be submitted to Canvas, and what you will be submitting are the written solutions to the quiz. I'm not sure what we mean by on webcam. It's not going to be proctored, if that's what you mean. You won't need the webcam for that, but you will need the webcam for the exam. Right? The exam will be proctored using HonorLock. I'm going to make this another announcement. The exam, not the quiz, the exam will be proctored by HonorLock. Good news is you don't need to buy any HonorLock tokens or any bullshit like that. We finally got a universal license for all students at Santa Fe to use HonorLock. So you'll need a working webcam. And reliable internet. Wednesday of next week. You can go to Canvas. I said Canvas. You can go to campus. You can go to the actual physical Santa Fe College campus and use their internet. It's stable. You can do that in the library. You can rent out a study room for that purpose. It just has to be somewhere that you and only you will be. So maybe an empty classroom would be okay. There's lots of those. If you want somewhere that you guaranteed privacy, I would try to rent one of the individual study rooms in the library, something like that. Does that answer your question, Lily? Okay, cool. The test is going to be 75 minutes, normal class time. The quiz, I haven't decided yet. I haven't structured it yet. So I will let you know. But the time limit there will be in WebAssign. It'll probably be like an hour, something like that. I'll give you an hour to do something like 10 questions. I'll talk more about the format of the exam, exactly what you're required to do when we get a little bit closer on our review day. I'll go through in detail exactly what you need. Again, I haven't structured it. I think what my default setup on WebAssign for quizzes right now is 3 attempts per problem. I might scale that back a little bit because this is a little different than what I normally do with my quizzes, but there will be one. You can run through the quiz only once, and then each problem you'll have 1 or 2 attempts. No, the free version, yeah, good question there. The free version of Cam Scanner works great. You're welcome to use that. I think last spring during the COVID outbreak when it first started, they were offering anybody who had an email affiliated with a school or university, like your SF College email, access to the premium paid version. But the free version is great. And yeah, it's in the App Store for iPhone. It's also in the Play Store for Android. If you happen to have an iPhone, then you can also use the Notes app there. That is capable of doing a good scan and convert to PDF. But I recommend Cam Scanner. It also stores everything on the cloud in a nice place. I'm not shilling for them, I promise. If you find a better app, please tell me. But right now, Cam Scanner is the best I've got. All right. Any other questions about this sort of bookkeepy announcement-y stuff? So Benson, the answer there is no, you don't need to pay for it. Although there is a paid version, the free version just has ads and it's every bit as good. All right. Okay then, so I want to come back to that topic of even and odd functions. Hopefully everybody was able to spend some time reviewing the Patrick JMT video that I posted, but I think still a little bit more connecting is worth doing. So let me remind you. This was what, section 2.7, right? 2.6, yeah. So our wrap up of section 2.6. So you might be wondering, why does this show up in the section on transformations? Even and odd functions, isn't that its own thing? And yes and no, both are true. So first the definitions. F of x is called an even function if f of negative x is the same as f of positive x. For example, the function f of x equals 1 minus 2x to the 4 is even. Because f of negative x, and you have to be remembering your function notation. If there's one super important thing in this class, it is that you get comfy with function notation. F of negative x is what you get by everywhere in the formula for f of x swapping in a negative x, but you do so in parentheses. So this would be 1 minus 2 times parentheses negative x to the 4, which is the same as 1 minus 2 times negative 1 to the 4 times x to the 4. Because having this negative here is the same as having a negative 1 times x. Negative 1 to the 4 is 1 though. So this is 1 minus 2 times x to the 4, which is the same as the original. So f of negative x is equal to f of x. Therefore, f is even. Let me say it like this. So f of negative x is equal to f of x, which tells us that f is even. So if I ask you, is this function even or odd, or prove that this function is even or odd, or check if this function is even or odd, what you do is you take your original function and you look at f of negative x. If that can be simplified to the original, then your function is even. A function is called odd called an odd function if f of negative x is equal to the negative of f of x. So the same sort of thing, just a different output. So an example here, the function f of x equals x minus x cubed. Let's show that f is odd. Here what I would do, just like in the other guy, I'm going to see what f of negative x simplifies to. For this guy, f of negative x, again, everywhere there's an x, I come in and in parentheses, very carefully, I swap each x with negative x. So this is negative x minus negative x all cubed. That's the same as negative x minus, and then here this negative is a negative 1 inside the parentheses, so that's negative 1 cubed times x cubed. And here, the parentheses, I don't have anything in front multiplying, and I don't have any power here, so I can ignore the parentheses there. That's going to be negative x. I'll do this here. This guy is just negative x without parens, because there's nothing multiplying and there's no power, minus, what is negative 1 raised to the third power? If I take negative 1 and I cube it, or I multiply it by itself 3 times, I get, yeah, negative 1. So this is negative x minus negative 1 times, and then x cubed is just x cubed, like this. Now this doesn't look like my original at all. I can say this is negative x minus makes plus x cubed. But that still doesn't look like my original at all. And remember, my goal is to show that f of negative x is negative f of x. So what could I do from here to make my original function show up somewhere in this mess? Does anybody see an algebra step I could take from that last line? Yeah, factor out a negative. If I factor out a negative here, I'll have the negative of this piece will become positive and this piece will become negative. And now this is my original function. That is negative f of x. So we've shown that f of negative x is equal to the negative of f of x, i.e. f is an odd function. Now you may notice some patterns. In the first original, f of x here, the even guy, I only had even powers of x. The 1 is really like x to the 0, and 0 is an even number. So if you only have constants and even powers of x, your function probably even. And over here, in the function that ended up being odd, I only had odd powers of x. This is not a coincidence, right? These names come from somewhere. The power of x here is 1, the power of x here is 3. Every power of x here is odd. So if you have a polynomial where all the powers of x are odd, probably an odd function. But if I ask you to show, or check, or verify, or prove that a function is even or odd, you gotta do this. You gotta do this. You have to show me that the definition of even or the definition of odd is satisfied. This is the definition of odd. This is the definition of even. So please commit those to memory and be aware that if on an exam or on a quiz, I ask you to show that a function is even or odd, this is the procedure you must go through. Questions on any of what we've done here? The definitions or the examples? Okay. The necessary kind of algebra things to remember. Useful tips. Negative x to any power is the same as negative 1 times x to that power is the same as negative 1 to that power times x to that power. All right, this is really what we're using in both of those processes. That's really just the one tip. This is a special case of the fact that if you take any two numbers and you multiply them, then raise to a power, that's the same as the first number to that power times the second number to that power. So these algebra rules, so important. Of course, oh, okay. Sorry, here we go. We can't get there by plugging in individual numbers, no. So if you want to prove that a function is even or prove that a function is odd, you need to look at f of negative x in general. So you can't plug in negative 1 or negative 2 to get there. You have to show that f of negative x, the whole algebra thing, simplifies to f of x, right? So what I did here, this is an example of a solution that would get full credit for a problem like that. The words special case of. So this tip, this algebra fact that is so useful here is a special case of the more general rule, this. So Leonie asked a question there. I'm glad you asked that because I do encounter that from time to time when I'm grading these sort of problems where you plug in -1, -2, and then you try to show that that has the same output as plugging in 1 or 2. But that doesn't prove that a function is negative. You can have functions that satisfy those things for a few numbers, but don't satisfy them everywhere. So in answer to Leonie's question, you really do have to do this whole algebra thing. You have to show that f of -x, the entire algebraic structure, the entire formula, simplifies to negative f of x. Or if you want to show that a function is even, you have to show that f of -x, the whole algebra structure, the whole formula, simplifies to the original f of x. Does that answer those questions? Do we want more detail here, more examples? How do we feel? Sure, we can do one more. I'm going to tuck it down here to be a little conservative with my paper. So let's show, or let's say prove, that f of x equals 1 over x squared plus 1 is an even function. So we need to show that f of -x is equal to f of x. That's my goal. I'll zoom in here. F of -x is what I get by taking my formula for f of x, and everywhere there's an x, I write parentheses -x instead. So this would be 1 over parentheses -x squared plus 1, like this. And now downstairs there, I can simplify. That's 1 over -1 times x all squared plus 1, like this, right? -x is -1 times x, which is 1 over -1 squared times x squared plus 1, like this. But -1 squared is 1. So this is 1 over 1 times x squared plus 1, which is 1 over x squared plus 1, which is the original function, f of x. All right, so this is what a good solution to a problem like that looks like. We have to do the full formula, can't just plug in a number or two. And we have to show that that formula for f of -x simplifies to the original. That's how you would show that a function is even. Because we're trying to show that this formula is true for this function. Okay? All right. So, how does this connect to transformations? Even and odd functions and transformations. Recall, f of -x is has the same graph, has graph flipped horizontally from the graph of f of x, right? That's a horizontal scaling. Oh, goddamn camera. I swear to fuck, this thing is just trying to drive me crazy. Focus, you piece of shit. F of negative x has graph flipped horizontally from the graph of f of x, right? Multiplying on the inside by -1 flips you horizontally. Yeah, it should be coming into focus now. I'm sorry, this dot cam is ancient. And also, negative f of x, his graph is flipped vertically from the graph of f of x. So when we say f of negative x is equal to f of x, i.e. if your function is even, this means flipping horizontally doesn't change anything. And if we say f of negative x is equal to negative f of x, this means flipping horizontally is the same as flipping vertically. All right? So f of negative x is what you get by reflecting the graph of f of x over the y-axis, by reflecting horizontally. If I say that that is equal to the original, that means when you flip over horizontally, you get the original back. So flipping horizontally doesn't change the graph. So for even functions, flipping horizontally doesn't change the graph. This is a symmetry. Here's the definition of an odd function. And this says that if you flip the graph horizontally, you get the same thing as if you flip the graph vertically. So odd functions have a symmetry where if you flip horizontally, you get the same thing as if you flip vertically. We call this first guy y-axis symmetry. And even functions have this. Because even functions are the functions that satisfy this relationship. And yeah, this second piece we call origin symmetry. So here, let me draw an example of an even function. Right, this guy would be even. Because if you flip him over the y-axis, he doesn't change. because f of negative x is the same as f of positive x. Flipping horizontally gives you f of x back. On the other hand, a function like this here, certainly flipping horizontally does change things. But if you were to flip horizontally, you get the same as if you were to flip vertically. So y-axis symmetry, remember, means flipping horizontally doesn't change anything. This would be an odd function. It has what's called origin symmetry. Which means flipping vertically does the same thing as flipping horizontally. And I really want you to look at these pictures with me for a minute and think about this shit. If I flipped this guy over horizontally, then this hill would be over here, and this valley would be over here. If I flipped this guy vertically, then this hill would come up here and become this valley would come up here and become a hill, and this hill would come down here and become a valley. So you get the same thing if you flip horizontally as if you flip vertically. That's origin symmetry. Think about it carefully. If I could pick this up and spin it around like that, the whole picture turns over, which is the same thing as what I'd get if I flip it over like this. So a horizontal reflection is a reflection about the y-axis, and a vertical reflection is a reflection about the x-axis. Another way to think of origin symmetry is if you take a point over here and you reflect it through the origin, you'll land back on the graph. That's another way to think about origin symmetry. So if the flipping both ways being the same doesn't satisfy you geometrically, you can think about it that way also. But I encourage you to think about it the way I described. Flipping vertically is the same as flipping horizontally, because that translates immediately into the definition here. I'm going to bring up Desmos for a minute and help you see this. It makes sense because we usually think of x's as horizontal stuff, and they are. Here's the function I had in mind when I drew that. Now, here's f of negative x. F of negative x is normally what you get when you do a horizontal flip. And you see the blue is what you get if you flip the red horizontally, right? If you were to pick, I wish I was standing in front of a board so badly right now, but if you pick this red graph up and flip every point horizontally, this point goes here. This point would go here. This point would go here. And it's the same thing you would get if you take this red graph and you flip it vertically. This point would go here. This point would go here, right? So a vertical flip is the same as a horizontal flip. Here's the vertically flipped. right? And what you see is that the green and the blue are the same. The blue is the horizontal flip, and the green is the vertical flip, and those two are the same. So this exhibits origin symmetry, is an odd function. All right, you may want to rewatch that part and follow what I'm saying very carefully. Remember, this is the horizontally flipped version because it's f of negative x. This is the vertically flipped version because it's the negative of f of x. And what we see is that the two graphs, the blue and the green, are the same. A horizontal flip does the same as a vertical flip. And the fact that this is equal to this is literally the definition of an odd function. So being an odd function and having this sort of symmetry are equivalent. So every odd function has that symmetry, and conversely, any graph with that symmetry must be the graph of an odd function. All right. So that's really all I wanted to say and do about even and odd functions. It's more than enough to get you through the homework. If you need more time on that homework, if you didn't like the Patrick JMT video from last week, I totally understand. Just submit an extension request and I'll be granting it. I've gone through there twice today and I'll do another one. Yeah, Patrick really is wonderful. I love those videos. They helped me a lot when I was in college. I think some of them date back to like 1999, but they're very, very good. So I encourage you to check them out. All right. So what we need to be talking about this week, the new material for this week, is on combining functions, which I believe is section 2.8. It might be 2.7. Let me see. Combining functions. Yeah, 2.7. So that's what we're going to start on now. 2.6 was transformations. 2.7 is combining functions. And most of this is really easy, but some of it, particularly the composite functions, are really good. Yeah, organic chemistry tutor on YouTube is also quite good. I've had a handful of people say they really enjoy his videos. And I think I may have 1 or 2 links to him in the Canvas resources, but check them out. Yeah, I encourage you guys to do that. So thank you, Lily. Combining functions. There's a few basic ways you can combine 2 functions. So given 2 functions, f and g, we can put them together, i.e. combine them, to make new functions. According to the rules I can make a new function that I call f plus g. I can make a new function I call f minus g. I can make a new function I call f times g. I can make a new function I call f over g, and then everybody's favorite function f circ g, and the function g circ f. This is an open circle here. So just like the originals are named f and g, when I write them down, I write f of x and g of x equals, and then I give you a formula that tells you how to compute the values of the function. So the new function f plus g, if you want to write down the formula, follows from the rule that f plus g of x is f of x plus g of x. The new function f minus g follows the rule that f minus g of x is f of x minus g of x. I know it's so exciting, right? F times g of x, again, super creative, is f of x times g of x. F over g of x is going to be f of x over g of x. These two down here are the real reason we teach this section. This stuff, think of this as being like boring intro, help you with notation, get comfy. These are open circles down here. And they stand for composite functions. Yeah, so both of these, this is f, and then a little open circle in the middle, and then g. And we read this as the composite of f with g, or f of g. And it's defined to be what you get when you take g of x and shove it inside f as an input. So it's f of g of x. That's not multiplication, it's function composition. And then this last guy is what you get when you do the same thing but in the other order. So this is g of f of x. Yeah, so I'm sorry, I left off the of x's here, like this. Some rules. For each of these guys, the domain will be the overlap. The math word for that is intersection of the domains of f and g. The other guys don't follow quite a simple rule. The domain here is the overlap, but you also have to kick out anywhere that f and g, or that g, sorry, the downstairs is equal to 0. So here, the domain is the same as above, minus whatever makes g of x equal to 0, right? Of course, because you can't have the denominator equal to 0. These guys, there's no nice rule for the domain. But these are the rules that allow us to combine two old functions and make a new function. You can do all the normal algebra shit, add, subtract, multiply, and divide. But then you've got these two new rules. Gabrielle, I'm sorry to hear that. Is anybody else having problems staying connected to the Zoom meeting? Shit, that's not good. So good news is I'm recording these locally on my computer. I'm not relying on the cloud. I don't know why you would be getting kicked out. I have to assume that Zoom is having some trouble on their back end because it has not crashed here for me. Shit, I'm so sorry, guys. Do your best to follow. The recording is being done locally on my computer, so when I get it on YouTube, I promise it won't have any cuts or anything like that. Is what an H? Benson, where are you looking? After domain is same as above, minus whatever makes g of x equal to 0. So this is f over g of x equals f of x over g of x. This is f of x, f times g of x equals f of x times g of x. Yeah, no h's anywhere on the page as far as I'm aware, aside from in the words written there. So this says the domain will be the overlap, parentheses, intersection of the domains of f and g. Yeah, domain will be the overlap, parentheses, intersection, close parentheses, of the domains of f and g. And then this says, yeah, domain is same as above minus whatever makes g of x equal 0. Yeah, Lily's got it. So after the word above, the word here is minus. So we'll do an example or two. And then we're going to talk about these guys. These guys are called composite functions, functions that are made by plugging one function into another. And it's really these guys that we want to understand. But in order to get to a place where you can really understand these, you need to practice with these, get comfy with notation and the meaning. Is anybody else having a hard time reading anything here or seeing what any of this says? Anything else causing trouble or anything else we'd like to ask about before I move away from this page? Isaac, you good? Okay, so quick little example. If f of x is the function square root of x minus 1, and g of x is x squared, find f plus g, f times g, f over g, and their domains. So you're going to have a few problems like this in your homework this week, where I give you a couple functions and then I ask you to combine them in a certain way and tell me the corresponding domains. It's worth starting by finding the domain of f and g on their own. Let's find the domains of the original functions. So to find the domain of f of x, the way I describe this to college algebra students is I tell them to look for red flags, right? Like you go on a date with somebody and he tells you that he hates his mother, red fucking flag, right? Watch out. Here is a function, and the sort of red flags that we watch out for when we're looking for domains of functions are even roots. Those are square roots, fourth roots, sixth roots, 10th roots. Variables in the denominator, and variables inside of natural logs or any other logarithm functions. We haven't talked about log functions yet, so I'm not going to hit you with any of that stuff yet. But do I have any red flags when I look at f of x? So remember we said the two that we're watching out for right now are even roots and the variables under even roots and variables in the denominator. I do see a red flag here. I've got an even root, right? The square root is an even root. It's the second root or the 1/2 power. So remember, stuff under a square root requires that that stuff is greater than or equal to 0. No, you're good, it's okay. Yeah, so the red flags are variables under even roots and variables downstairs. So here I do have some variable stuff under a square root. So the domain of f will be found by setting x minus 1 greater than or equal to 0. So yeah, good. This is the same. I can add 1 to both sides. This is the same as saying x is greater than or equal to 1. So x cannot be less than 1. Or if you like, just say what it can be. X can be greater than or equal to 1. So the domain of f is this in interval notation. I would write that as 1 to infinity. It's closed on the left because this is greater than or equal to. So 1 itself is okay. And we have to be bigger than positive 1. That's the way that shakes out. Remember also you could get this as a translation of the square root function, right? The graph of f of x is the square root function shifted to the right by 1 unit. So here's the graph of f. So his domain is just this stuff. which is this interval. That's correct. Yeah, so what Lily said in chat there is correct. Square roots are a red flag. Odd roots are okay though. Cube root, fifth root, those are fine. Square root, fourth root, those are dangerous. G of x is a polynomial. He doesn't have any red flags. This is a polynomial. No red flags. So the domain is all real numbers. Negative infinity to infinity. Okay, so we wanted to find f plus g, f times g, f over g, and their domains. We're going to use this as a jumping off point. We can come back and compare what we get to what we said earlier. F plus g of x is always f of x plus g of x. And I strongly encourage you, even though it might feel silly, to write down this starting step. I won't ask you for ranges unless I give you a graph. Yeah. I won't stress you on that, just domains. So when you go to do something like this, like find a formula for f plus g, you should always begin by writing down this step, because this step will tell you what to do next. It says, okay, you want a formula for this, take the formula for f and add it to the formula for g. Well, what is f of x? The formula for f is the square root of x minus 1. And the formula for g is x squared. So I take those two and I add them. So while we're not worried about ranges here, I won't ever bug you about the range. I am going to bug you about the domain. Earlier we said that the domain of f plus g should be the overlap of the domain of f with the domain of g. What is the overlap between this interval from 1 to infinity and this interval, which is all real numbers? Did everybody hear me there? Yeah. So we want to take the overlap, what's common, the intersection between this set and this set. So if you drew them both on a number line, we want to know what is common to both. You could also play the red flag game with this formula. This guy has no red flags. This guy does. We need to make sure that this stuff is greater than or equal to 0. So either way, you're going to get this. So it's the overlap between the interval from 1 to infinity, closed on the left, and the interval from negative infinity to infinity, which is just 1 to infinity. So this would be my domain here. What's up, Fabrice? Am I saying your name right? Fabrice? Fabrici? Fabrici?
No, it's Fabrice.
Fabrice, I'm so sorry. What can I do for you?
I'm just confused.
So what's feeling confusing? Where did I lose you?
That wood stuff requires tough stuff and...
Say that here?
Yeah.
So what sort of numbers can I take the square root of? We're trying to figure out the domain of this function, right? The square root of x minus 1, that's what we're trying to do here. This function is defined by the rule, take your number, subtract 1, then take the square root. The domain, remember, is the set of all possible inputs. What sort of x's can I plug into that function? The only thing here that can get us in trouble is the square root, right? So I ask, what sort of things can I take the square root of? If I want to take the square root of some stuff, that stuff needs to be greater than or equal to 0, right? You can't take the square root of a negative number. You get imaginary numbers. It's no good. So we're only interested in x's which will allow me to take the square root when I plug them into this formula. Those will be x's which make the stuff under the square root greater than or equal to 0. So to find the domain of this function, we take the stuff under the square root, which here was x minus 1, and we set it greater than or equal to 0. And then we solve that inequality by adding 1 to both sides. It gives me x is greater than or equal to 1. So maybe let me do this. Let's do a quick recap here. I know we're running short on class time. We'll pick it up here on Wednesday. Let me finish this problem, and then I'm going to give you guys a rundown of that domain stuff, because I know, again, it might be a minute since you've taken a math class or whatever. So here, the domain of f plus g is the overlap between the domains of f and g. The domain of f is this, the domain of g is this, and if you look for the overlap, it's just this. Or play the red flag game with this. And the red flag game is what I'm going to summarize for you after this in case you've forgotten. But in order to keep the class on track, the next thing we need to do is find f times g. And again, my suggestion is to always write down this kind of silly looking first step. F times g of x is always f of x times g of x. Here, f of x is the square root of x minus 1. And g of x is x squared. So this is the function f times g. And his domain is also going to be 1 to infinity. Again, you can think about it as the overlap of the domains, or you could just play the red flag game with this piece on its own. Finally, f over g is always f of x over g of x. We're going to write this down. That looks like the square root of x minus 1, that's f of x, divided by x squared. That's g of x. So here, I would need to play the same game. I'm going to take the overlap, and then I'm going to kick out anything that makes the bottom 0. G of x is equal to 0 if x squared is equal to 0 if x is equal to 0. So 0 is not in the domain. And then upstairs, I have the restriction coming from the square root function. His domain is 1 to infinity, which already doesn't have 0 in it. Yeah, if you're having a hard time seeing the overlap, draw the two domains on the number line, shade them, and then see what gets shaded twice. So the domain here, it's still the open interval from, the left closed, right open interval from 1 to infinity. So it sounds like we need a little review of how to find domains, and that's fine. That's, instead of moving on to more examples with the composite functions, that's what I'm going to do in these last few minutes. What Lily said in chat is great advice. If you're trying to find the overlap between two sets of real numbers, you should draw them on the number line. Even before we talk about that, let me summarize these red flags. Okay, I'll give just a second here for anybody who's still writing. Please get this down quickly, and that way we can use these last few minutes of class well. Okay. Finding domains algebraically. In our very first lecture of the semester, we talked about how to find domains from the graph. But we haven't talked about how to find them using algebra. It's something that we're supposed to learn in previous classes, and we'll of course go over again here, but let's take a second. So here's some language and some metaphors that might help you internalize this. You look out for red flags. Right? I like this metaphor. The example I usually use if you're going on a date with somebody and they tell you they hate their mother or they hate their father, generally a red flag, right? If a man tells you he hates his mother, probably got mommy issues, that sort of thing. Functions have red flags too. Shit you gotta watch out for. Variables under square roots. Variable quantities. Not just under square roots, but under any even root. Those are like square roots, fourth roots, sixth roots. So for example, the square root of x, he's got a red flag. The square root of x squared plus 1, he's got a red flag. The square root of 1 minus x squared, he's got a red flag. All of these have red flags. Here, to find the domain issues, or to find the domain, set the stuff under the square root greater than or equal to 0. Because we cannot take the square root or the fourth root or the sixth root of a negative number, I need to make sure that the stuff that's under my root is not negative. What does it mean to be not negative? It means to be bigger than or equal to 0. The other main red flag you need to be concerned about right now are variable quantities in denominators. So stuff like 1 over x, or 1 over x squared plus 1, or 1 over 1 minus x squared. And here, to find the domain, set the stuff in the denominator equal to 0, then kick out those x values. So a red flag doesn't always mean bad news, you know, it's just a warning, right? For example, well, let's start with something like this. So find the domain of f of x equals 2x minus x squared over 3 plus the square root of x. I go hunting through this formula, looking for any red flags. This piece, no red flags. No variables under square roots, no variables in the denominator. He's fine. This piece, again, no red flags. He's got an x squared, but that's not a root. And he's got a thing downstairs here, but there's no variables downstairs. So this whole piece has no red flags, no domain restrictions. This piece, however, does have a red flag. This is an even root, it's a square root, and I've got an x underneath. So the only red flag is the square root of x. So we need the stuff under the square root to be greater than or equal to 0. That's the only red flag, and these are the conditions that make sure we stay out of trouble. So the domain is just that. It's all the x's which are greater than or equal to 0. That's the left closed, right open interval from 0 to infinity. If I wanted to look at an example of the other sort, let's do it like this. Here I do have a red flag. I've got variable stuff downstairs. It's the whole thing. So we need to find where x plus x cubed is equal to 0 and kick those out. X plus x cubed is equal to 0 is the same as saying you can factor in x, x times 1 plus x squared is equal to 0. This means either x is 0 or 1 plus x squared is equal to 0. 1 plus x squared is never 0 though. This has no solutions. So 0 is the only problem. So our domain is everything but 0. So our domain here is all real numbers except for 0. That's negative infinity up to 0, unioned with 0 to infinity. You punch out 0. All right, these are the basics of finding domains using algebra. What we're doing when we start combining functions is we're looking for the overlap in the domain between two functions. So again, we're very, very short on time here. I have to keep moving. So last little point here to wrap up what Lily was saying in chat. Yes, the easiest way to find the overlap between two sets, if f of x has domain, let's say negative infinity up to 3, and g of x has domain negative 2 to 7, then f plus g has domain. We need to look at the overlap. So here's negative infinity up to 3. Okay, I'll put 3 right here. So negative infinity up to 3 looks like this. And it goes on and on and on forever that way. Negative 2, I'll say maybe negative 2 is right here, and 7 is over here. So the domain of g of x, I'll shade this the other way. Looks like this. So the domain of f plus g, f minus g, and f times g would all be the overlap of these two sets, which is this shit right here. The shit that got shaded left and got shaded right. That's negative 2 to 3. It's open on the left and closed on the right. This is what we mean when we say sketch the domains to find the overlap. Okay, we are a little bit more than out of time, so I have to stop the class today for right here. We did not get to talk about composite functions. So that's where we're going to pick it up on Wednesday. We will talk about composing functions and finding domains of composite functions. We'll also do more examples like this, where we're finding domains of f over g or f times g. But where we're going with this is we're going to start studying inverses and the algebra you can do with functions using that composite operator, the circ or the fog thing, where you plug one function into another. We'll be doing that to start talking about inverse functions. Once we've finished talking about inverse functions, we will be ready for the test. So probably Wednesday, we will finish the material that is necessary for the test. I will release the study guide and quiz. Remember, the quiz on WebAssign is the study guide. If you don't remember exactly how you're expected to do that and turn it in, go watch the beginning of this video. I will release that on Wednesday of this week, and then we'll have the test the following Wednesday. I am also opening up a homework today. There will be a homework on this material that you need to do. So you're going to have several things due over the next week. It's important that you keep on top of them. There's going to be the quiz and the homework in WebAssign, and then your solutions to that quiz, which you will rewrite nice and neat and perfect and as well as you possibly can after taking the quiz. You will submit those on Canvas as your study guide. If you have any questions or if you're at all unsure what you're supposed to be doing or how it should look or where you should put it, please contact me and ask, and I'll be happy to talk with you about that stuff, okay? But for now, we need to go ahead and end the class because I've got an office hour I need to start. If you want to talk more about any particular problems, feel free to meet me over there or send me a message on Canvas or email. And that is it, guys. So I will see you all on Wednesday. Please try to stay on top of the homework and watch for the new homework and quiz to drop. They'll be coming out just a little bit later today. Anything urgent before we sign out? All right, hang in there. You guys are doing great. Stay brave, keep working, and I will see you on Wednesday.
Thank you.
Of course.